Hello, Adab, Namaskar. Welcome back to ptscadexpert. So in this video, we are going to learn Revit architecture and the different aspects which are very important inside Revit architecture. And one of the most important topic is facade designing. So as you can see, this is a different type of facade and it's a most modern type of architecture in facade, as you can see in this image. So if you want to learn or want to make such kind of facade, so you have to learn the basics first, like how to make plans, adaptive modeling, mass modeling, different planes, points and the lines. So once you will play with these basic steps, then you can make these types of facade inside Revit. So for that, first you need to learn like how to start Revit architecture, and if you're already beginner in this software, so you can make such residential or commercial project. But once you'll come to the facade point, then there are many conflicts and there are many confusion like how to achieve such type of results. So in this video, Mr. Kumar Kapadia will teach you the basics of facade designing, like if you want to make a twisted building and if you want to make like that type of polygonal shape and this types of building and such types of typical shape inside Revit. So step by step you have to watch the complete video, and definitely you will get the complete details of facade designing once you will finish this video. And if you are a regular viewer of ptscadexpert and if you are coming first time and want to learn Revit and the other designing software in this platform, so let me introduce some of our most important videos which are we have already made on Revit architecture. So that video, you can see this video, it's approx 8 hours of video and you will learn the complete basics about Revit, and about Revit MEP you can watch this video, and all those links you can find inside the description. Apart from that, we have recently started a detailed tutorial on the different softwares like Civil 3D, you can see D5, AutoCAD tutorial, where we have covered more than 25 types of like how to make working drawings and the other aspects. Apart from that, you can also see the Lumion. If you want to like if you want to make such details walkthrough, HD walkthrough, 4K walkthroughs, then you have to learn Lumion, and with this video you can achieve such results. Apart from that, if you want to learn complete industrial details software with the industry professionals, then also you can install our mobile application where you can find more than 65 plus AC industrial software where you can learn BIM, designing software, structural software and the planning programs. If you find this video informative, then hit the like button and subscribe the channel. So without getting late, let's get started.
Hey, what's up guys? Welcome back to ptscadexpert and myself, architect Kumar Kapadia from the city of Surat in Gujarat. And today's exercise is going to be all about modeling this particular creative parametric installations in Revit using different template files of Revit and using different nested and embedded families. So if I take you to this particular playlist Revit BIM on ptscadexpert channel on YouTube, earlier we had modeled this particular London Twist Museum in conceptual mass environment of Revit. Fine. So using the same template file, but slightly with different tips and tricks, we are just going to model this couple of parametric installations, which will involve the modeling using different template files like conceptual mass environment, generic model adaptive template file, and generic model pattern based families. So it's going to be a very informative tutorial. So watch this entire tutorial to the end, and if you think that this particular video was worth, then kindly enroll for this particular course Revit BIM, which is the combo of architecture plus structure plus MEP. Fine. So now without wasting a single second, let's jump into the interface of Revit and let's start designing this particular creative installation in a fresh new project environment. And from here, I'll just go to this particular template, English Imperial, and I'll select open up a new architectural template. Fine. And for the sake of reference, I will create one base plate. Okay. So this, as I said, this is going to take into consideration different template files. But the core is that this particular form will be modeled in conceptual mass environment. So I will say that in place mass, and I will just define one new mass. Okay. And reference line, and I'll just drop one line and go to 3D. And I will just select the particular line and say that divide path and say that 10. Fine. And if I just take it to this particular file, then you see that this particular model, this particular elements this is a nested and embedded parametric module which is repeating across this particular path, across this particular points in a different way. Fine. So we are just going to do that. So yes. So let me just open up file. And as I said, we are going to take into consideration different template files, new and family. And this time I'm just going to go to this particular family templates, English Imperial, and I'm just going to open up this generic model adaptive. So adaptive family involves the modeling of points with adaptive values, which adapts to the values in the project environment. Okay, so I will just say that points, and I will just drop 2 points. Okay, and I will select this particular points and say that adaptive. Okay, then I will select this particular 2 points and say that spline through points and convert that line into a reference line. Okay, now I will host a point onto this particular line somewhere. Fine, and if I just go to just select this particular point, and if you see that this normalized curve parameter is reading this particular value, but that's okay, we will change it later. So what I'm going to do is that I'm just going to set work plane and select this particular vertical plane associated to this particular point. Okay, and then with that I'm just going to say that inscribe polygon, and I'm just going to turn this into 5 sides. Select this point and roughly draw a polygon. Okay, and I'm just going to convert this into a reference line as well. Okay, now I'm just going to host another point somewhere on one of its segments. Okay, and with that set work plane, and again select the same associated vertical work plane to that point, and send again define and inscribe polygon, but this time I will say that this should only be 4. Okay, and I will just define one square. Okay, and turn it into reference line as well, and then I will just dimension it, say equal, and one overalls from here to here, equals, and one overall. Okay, and now I'm just going to convert both this into a parameter so we can control its size in the project environment. So this is going to be D for depth, and this is going to be W for width. Okay, and just go to the particular family types, define a type, let's say A, and for A I'm just going to say that the depth should be 1 feet and W, that is width, should be 15 inches. Fine, and just apply and okay. Okay, fine. With this I will just select this particular point, select this polygon, and say that create form. Okay, next is that if you just watch this particular installation, then you see that every instance of this particular parametric module, when placed across this path, you see that it's changing its angle. Fine. So we need to establish a couple of parametric relationship and also associate this particular point, the angle parameter associated with this point, into a parameter. Fine. So just try to follow. I'll select this particular point, and you see that this is having a rotation angle. So from here, if I just rotate this, then you see that this entire form will rotate. I'll just click undo. Again, select this particular point and convert this particular parameter in this particular field, and associate that and create one parameter calling it R1. Okay, and turn it into an instance parameter. Fine, and okay and okay. Fine. Now I'm just going to select this particular point, and you see that it has this particular normalized curve parameter. Let's try 0. Yeah, okay, fine. I will just bring that particular module up till this point. Now, as I said, that this module, when taken to the project environment, with that every instance of this module placed, I want this particular module to rotate and have different rotation angle. So we need to establish parametric relationship of this element, of this point, with respect to this point, and create a reporting parameter. Fine. So I will just click this particular align dimension and say that set work plane, and set this particular work plane, and select this point. Watch this point, it should read adaptive point 1, and select this point, press tab until it reads adaptive point 2, and create one dimension. and I will just convert this dimension, temporary dimension, into permanent parameter, calling it distance, this for short. And I'm just going to convert it into an instance and reporting parameter. Why? Because I want to report back to the values in the project environment. Now I'm going to establish a couple of computational relationship. Fine. Computational parametric relationship. So for that, I'll just select this particular angle, or fine, let's create one more new parameter, new, and that would be, so not edit, create new, and that would be R2. And that would also be an instance, and that should be an angle parameter. Fine. Okay. Now I'm just going to use a computational formula in order to drive this radius with the help of this particular reporting parameter distance. Fine. So what would be that? So open parentheses, this distance, which is then reporting parameter, divided by any value, let's say 4 feet for instance, and close parentheses, and that should be times R2. Okay. That is this value, and I'll just pick enter. But right now this is 0, so that's why this is also reading 0. If I change this to 5 and just enter, so this will adapt to some value, and I'll just say that apply, and you just watch the change here. So you see it's rotating. Now since we have established this computational relationship, now if I select this particular point and if I just drag it, you see that it's rotating. Fine. So we are going to place this particular module in such a way in the project environment that will use this particular computation. Fine. And this is family 3. And now I'll just load this into the project. Fine. And I'll just select this point with place on work, place on face, not place on work plane, place on face selected. Select this and select this. Okay. 1, and select this and another instance 2. Fine. So you see that it is the instance is changing its angle. Fine. Let me just delete this, and let's say that let's make this something like 150, some bigger size, and then select this and divide path and say that let's say 14 of them. Yeah. And then say that create and component 1 to 2 and 1 to 2. Okay. And with that selected, what I'll do is that I'll just press repeat. Okay. Just ignore this particular one and just delete it. And you see that you have that particular thing achieved. Okay. Now, if you want to play with the material parameter, wherein you want the different modules to have different materials, then what you have to do is that just go to this particular environment, this particular template file, and herein just go to family types, and with this A define, first is that I select this and I will select this particular module, and you see that it has this built-in parameter material, and I will create this particular, click this particular button and turn it into a parameter, calling it module material, and I'll keep it as a type parameter. Okay. So we can have different materials for different types. Okay. And now I'll just go to the particular family type and define one more type, calling it new and calling it B. Okay. And fine, apply and okay. Fine. With this, I will just load this back into the project, override existing version. Fine. And I'm going to select this bunch, this series of modules, and drop this down, and you see that now we have 2 different types for this particular family, and I turn it into B. So with this, what you can do is that select this and go to a type, and since this module material is a type parameter, you can apply this material to this. Okay. And likewise, you can select this particular bunch and this sets of elements of this set of module, go to edit type and define a different material for that. Okay. So finish mass and just select this particular thing, edit boundary, and I'll just make it a little bit bigger. Okay. Fine. So with this, now what next is that this particular thing, and it is nothing, it is absolutely perfectly the same thing, but it's having a different size. Fine. So I'll just show you that. So what I'll do is that I'll again come here and define one more type with smaller value. So that would be C. Okay. But for depth, I'm just going to turn it into 3 inch, and width, I'll call it 6 inch. Okay. Rest everything will remain the same, and apply. So you see that now it becomes the module size changes. Okay. And then load that back into the project, overwrite existing version and its parameters. Okay. And yes, since we had reloaded it, so we again need to, if we want to visualize the material parameter, then just apply it once again. Yeah, that's fine. Okay, now let's go to level 1, and herein edit in place, define one more line, reference line, just draw it. Okay, and come to here, close this because we don't need it. Select this particular thing, HL, divide path, and just select let's say 50 or 75. Okay, and then create a component 1 to 2 and 1 to 3. Fine, but select this particular thing and change it to C. Select this and change it to C again. Okay, and with this 2 selected, what you can do is that just repeat. Yes, so likewise you can have this particular form. Okay, R and char. But I guess that in order to have dense, you need to have more points. I just press undo and select this particular thing and change it to 125. Okay, and let's just say that create component 1 to 2, change it to size type C, and then just repeat. Oh, sorry, I need to do that again. CS, create component and 1 to 2. Okay, select that and turn it to type C as well, and then select both of them and then repeat. Fine. So you see that each instance of that particular element when placed is changing its angle depending upon the distance from this point. Fine. And this is how we have defined that particular installation. Okay. Next is this particular thing. Okay. And that will also be created the same way but slightly using a different method. So let's quickly do that. I will just close this, and again I will say that drop a reference line, draw on work plane on level 1, and I will just draw one simple line of let's say 75 feet. Okay, and I will go to front elevation and elevate that line. While checking this joint checked on, I will just move it 5 feet above. Okay, HL. Fine, and I will host a point onto this 1 and 2. Okay, 1 is also enough. Then I'll say that set work plane, define that particular work plane, vertical work plane associated with that point, reference, and again a polygon having 4 sides, and I will just define this. Okay, and turn this into reference line. Yeah, that's a reference line. Okay, and I will just strike an align dimension from here to here, equal 1 overalls, and we cannot see that. So wireframe WF, I've added the shortcut. You can do it on your system also. Align one more dimension, 1 to 2 to 3, equal, and 1 overalls. Okay, and this I'm just going to say that D for depth, and this I'm just going to say W for width, and this I'm just going to change both of them to 10 feet, 5 feet cross 5 feet, or not 5 feet, sorry, I forgot the dimension. 10 feet cross 10 feet, yeah, because we have elevated that line 5 feet above. Okay, now what I'll do is that I'll select this entire thing, CEO, and move it somewhere outside. Select this particular point and say that pick new host and host it here. Fine. This I'll select, and since this point, the normalized curve parameter of that is near to 0, so I'll turn this to 0. And likewise, I'll select this, and this is closer to 1, so I'll turn it to 1. Fine? Fine. Next is, I'll just select this particular reference line, 1, 2, and 3, and just say that create form. Okay. Now, if I just select this particular point, you see that it has this rotation angle, built-in family parameter, angle parameter, of which if I just change this particular thing, then you see that it reports to the values, and you have this twisted form because this shape is driven by this point. Okay. So I'll just click undo and select this point and associate a family parameter to this, calling it R for radius, and that could be an instance. Okay. And with that, I'll just say that okay. Fine. I'll just go to this particular family types and change this R, this rotation angle, to 90. Okay. And just apply and okay. Okay. So with that, you see that we have achieved that particular form. The fundamentals and basics of this particular form we have achieved. Okay. So now what we need to do is that manipulate this particular surfaces. Okay. For wherein now we are just going to use a different template file and slightly manipulate this in a different manner. I think I'm just going to say that divide surface. Okay. And now in order to achieve this particular thing, you have to try various permutations and combinations. Wherein you see that if you just closely watch this particular thing, then there is two of them within one segment, within one divided surface. We have two modules. Okay, so we need to achieve something similar. So I will just select this particular divided surface and change this particular number to 25, grid rotation for this particular U grid to 30, and similarly for V grid I'll change this number to 25 again, and this to 60. That is because I have already tried this particular thing for that dimension. If you are dealing with a different dimension, then you have to try that particular thing. Okay. And you see that 1 and 2 modules within that particular this divided surface. Fine. So we need to do that for all the surfaces. I will just press tab and select that surface. Yes. And why is it not selecting the individual surfaces? You need to press tab a couple of times. Press divide surface, select that, and say that 25, 30, 25, and 60. Okay. Same for this. Press tab a couple of times until you find this surface, divide surface, and say that 25 and 30, 25 and 60. Okay, and last but not least, this particular surface, press tab a couple of times. Yes, and divide surface. Just say that 25, 30, 25, and 60. Okay, and you see that we have achieved that particular thing, wherein you see that this point, this particular lines are matching. Okay, so now what we need to do next is that we need to define a pattern based family onto this. Okay, so file and new and family, and this time I'm going to say that family templates, English Imperial, and I'm just going to use this generic model pattern base. Okay, pattern based family. And here I'll just quickly host a point somewhere over here, place on face, set work plane, select the vertical associated work plane to that polygon, and the same process that we did earlier. And just 1 to 2 and 3. Let me just first scale this down a bit. 1 to 2 and 3 and equal. Ever if you want to change this particular size in the project environment, so you need to associate that with the parameters. Okay, just change this to just convert this D for short, that depth, and this to W for width. Okay, and family types, and this to be depth to be 1 inch and width to be 1.5. Okay, apply and fine. With this, I will just select this tab 1, 2, and this 3 and say that create form. Fine. With this family 6, I'll just load this into the project. And with that selected, you just drop down. Since it is a pattern-based family, if you just drop this down, then you have that particular family here loaded under this rectangle pattern. Okay. Fine. Family 6. Yes. So you see that that particular element is manipulated across that entire form. And I will select all these surfaces, 1, 2, hold Control key and select all the divided surfaces, and just drop down and change it to family 6. Okay. And you see that we have achieved it. Okay. So this is the importance of renaming this nested embedded families, because one file might have lots and lots of families nested and embedded. So it's difficult to find when you want it. If you want to happen to have any changes within that nested and embedded families, you need to have that perfectly renamed. So whenever you want, you can search it from this particular project browser. Okay. Right now, just to save time, I'm not renaming it, but you guys don't forget to. Okay. Now we need to host the main component, this particular component. Okay. So how we will do that? So I will just select this 1, 2, 1 and 2. No, you have to individually get rid of this particular component and see this particular form. Okay. Until you can properly visualize this form. Okay. Now what I'm going to do is that I'm just going to create one more nested and embedded family, which is going to be again a generic model adaptive. So we have already used that file. So again, we are using that template file, and I will just create this 1, 2 and 3. Okay. Create this and make it adaptive. Select that spline through points and as a reference line, and I'll host a point onto this. Fine. And set plane, set work plane, and with that work plane selected, I'll just click this particular polygon, 4 sides, and I will just set plane, and I will just draw one polygon and dimension it. Let me just scale this down a bit. 1, 2, 3, equal, and 1 overalls. 1, 2, 3, equals, and 1 overalls. Okay, and select this and turn it into a reference line. Constrain in the sketch with the highlighter. Yeah. We should have turned that into reference line earlier. So I will just turn it into reference line first and then dimension it. That's okay. 1, 2, 3, equal, and 1 overalls, and 1, 2, 3, equals, and overalls. So this should be D for depth. This should be W for width. If you ever want to control its size in the project environment, I will change this to 3 inches and this to 6 inches. Apply and OK. Fine. And with that selected, I will just select this and create form. And you can also do a material, but right now I'm not taking into consideration the material part in project 5. Okay. And with that, what I'll do is that, see that 1 SM, that is middle, and SE, that is end. Okay. And that is how you have to place reference this particular element across all the edges. So just stay tuned. I will just quickly do the needful SM, SM, sorry, create component, select the start point, SM middle, and SE end. Okay, the wrong work plane is selected. Sorry, I will again say that create and component SS, that is start point, SM middle, and SE as end. Yeah, fine, that's okay. SS, SM, and SE. I'm going to repeat that same step for all the segments. So just stay tuned until I do the needful. SM, SE. Okay. Likewise, SS, SM, SE. Oh, the last one didn't properly, because I was not able to visualize. Create component SS, SM, SE, SS, SM, SE. Okay, SS, SM, SE, SS, SM, SE, SS, SM, SE, SS, SM, and SE. And with that, we are done. Okay. And now if I just press HR, sorry, not HR, I need to select this particular surfaces. 1, 2, or let's do it step by step. Component. You see that 1, 2, 3, and last but not least, yes, 4. Okay. And we have achieved that particular form, this thing. Fine. If I just select this particular installation and if I just temporarily isolate it, if you remember, then we have modeled this particular entire installation across this path, wherein across these 2 points, so 1 and this is the second point here, across these 2 points, 2 square profiles has been hosted, which has been given the rotation angle. Okay, this particular point, if you remember, then this particular parameter has been associated, giving it a rotation angle. So if I just go to the particular family types and if I just change this to 60, then you have a different result. And you can have n permutation and combinations of the same design. See, this is the result now. If I again change this back to 30, then you'll have a different result. And likewise, I have given the angle parameter to both the points. So I can have multiple options. Fine. But this was just to show you. Let's get back to what it was. That is, I'll just change this particular thing to 90 and 0. Apply and OK. Yes. Now, the last one is this particular thing, which we are again going to create slightly in a different manner. And if you just want to visualize the form, then let me just select this particular thing, HICC. Right? So this is the form which has been mirrored across this particular plane and with which we will be able to achieve this particular thing. Fine? Okay, so just try to follow and we will do that here. And select everything and just move it a bit so you can have a clear canvas space to work on. And I'll just go to level 1. Okay, and herein I'll just say that reference, and we are going to take into consideration a lot of construction lines for this, a lot of reference lines, and this should be 60. Okay, fine. And I'm just going to copy it multiple times, 5 feet and 5 feet again. Okay, and I will just draw one line, 10 feet. And we are going to model that, sorry, Li. 10 feet. And we are going to model that particular form across this 3 reference lines and then mirror it across this line. Okay. So what I was supposed to do first is that I will just say that I need a point 1, and I'll select this particular reference line and delete it. And just select this particular point and see that it has this offset parameter. Fine. I will just copy this 15, 1, 2, 3, and 4 times. Okay. And then I will select all of that and just say that spline through points, and that is a reference line. Okay. Now I'll select this particular points, and if you see that it has this offset parameter. So this 1, 2, and 3. There's 3 points I will select and select this. Okay, we'll do that later. First is that I will just select this particular thing as slightly, I'll give it a deformation and just move it like this. Okay, fine. Now I'll just go to 3D and I will just select this 1, 2, 1, 2, and 3 points and give it an associate this particular offset parameter and turn this button into the parameter, calling it H1. Okay, and I and this 2 I'm just going to select 1 and 2, and this offset parameter I'm going to associate, turning it into a parameter, calling it H2, height 2. Okay, 5. Now I'm just going to go to family types, and H1 I'm just going to turn it to 18 feet, and H2 I'm just going to turn it into 15 feet. Just apply. Okay, so you see that we have taken this particular spline, elevated the spline this phase. Okay, now what I'm going to do is that I'm just going to go to level 1. I'm going to select this 2 reference planes and DM and mirror it across this line. Okay, fine. So we have this reference line here as well. Now I'm just going to select this 1, 2, and this 3. Okay, no, we have to individually do it. So select this 1 and 2 and create form. Select this, press tab, and select this and this, and say that create form. Okay, so we have created that particular form which I just showed you. This particular thing, this we have created. Okay, fine. Now what we just need to do is that mirror this particular entire thing. Fine. So what I will do is that I'll just select this 1 and 2, go to level and DM and mirror it across this point. Fine. And yes. Okay. So we have achieved it. Now what we just need to do is that create a divided surfaces and host adaptive families onto that. Fine. So I will just select this 1, 2, and this is the divide surface. Okay, or from which I will just select this and get rid of U grid. And V grid, I will just turn it to something like 75. And this too, I will just get rid of U grid, and V grid, I'll turn it to 75. Fine, I'll select this and this both. And surface representation, no, you have to do it once at a go. Surface representation nodes, fine. And this too, surface representation nodes. Okay. Now, the last family for today, new and family. And again, we are going to go to family templates, English Imperial. And again, that will be a generic model adaptive. You see that a lot of families. But the only way out is that perfectly rename it once taken to the project environment. So, host a point 1, 2. Select that, turn it into an adaptive points. Select it, spline through points. Okay. And this should be reference. Okay. And then post a point over here somewhere, not important where. Set work plane. Select this vertical plane associated with this point and just draw a reference circle. Okay. And create this and turn this dimension into a parameter radius. Okay, and make it an instance. You can edit it instance in the project environment if you want. Just turn it to 3-inch, apply and OK. Fine. And then select this line and this circle and say that create form. Fine. Okay. So this is an adaptive. So you see that it flexes. You can flex it. Yeah. Fine. You can flex it. Okay. Now, family 8. Load this into the project and just go to 3D. 1 to 2. 1 to 2. Okay. And then just select this and say that repeat. Select this and say that repeat. Fine. And you have achieved it. So this is the same way, the same thing follows for this face as well. Nothing but just a mirror of that. Fine. And with that, if I just go to this and you see that from here, you can change the radius if you want. It's an instance parameter. Let's go for 1 inch. So that will reduce its diameter that way. If I say that 6 inch, then it will behave that way. I say that 3 inch. And also if you want to apply some material to it, then just come here, select this and associate the material parameter. Material, pipe material. Okay. And just click OK. And load it into the project. Override existing version in its parameters. Delete, and we don't need to save because it's already loaded. And herein, while coming to this particular family, select any one instance and go to edit type. And you will not be able to change from here, maybe from here, but now you see, this is the problem which I was talking about. How to make out that which family is this. So it is family 8, I guess. Yeah. So sash, apply and OK. Yes, see? Okay. So this is the way you can create such parametric stuffs and elements in Revit using conceptual mass environment and different files. Fine. So if you think that this video was worth, then kindly enroll for this course Revit BIM, which is the combo of architecture plus structure plus MP, and let's learn together and let's grow together. And if you have any doubts and queries regarding this particular exercise, then you can mention below in the comments and I'll reach out to you, each one personally. Thank you. Fine, and have a good day.